Close your eyes and picture this. You are standing in the middle of an endless plain where the boundary between the ground and the sky blurs into a blinding, infinite expanse of whiteout snowstorms. There are no sheltering trees, no protruding rock formations to break the gale. Here, on the Mammoth Steppe during the peak of the last glacial maximum, raging wind gusts regularly reached up to 100 miles per hour. They did not simply blow past you. They pierced through every layer of flesh and fabric, crashing the core body temperature of any warm-blooded creature down to fatal levels within mere minutes. This unrelenting harshness created an extreme survival crisis that no large animal could easily overcome without specialized adaptation. For those Paleolithic hunter-gatherer groups, this was neither a picturesque landscape nor a temporary adventurous expedition. It was a natural death sentence carried out day after day. From a purely biological standpoint, the human body is fundamentally ill-equipped to withstand such a hostile environment. We lack the thick blubber layer beneath our skin that marine mammals use to insulate heat. We do not possess the dense, coarse, waterproof fur of polar bears, and our physiology quickly succumbs to acute hypothermia when ambient temperatures plummet deep below zero. Without a revolutionary breakthrough in architectural engineering and structural design, humans would have long ago gone extinct on these desolate lands, fading into oblivion alongside countless other megafauna of the Ice Age. Yet ancient humans refused to surrender to fate. They engineered one of the earliest and most magnificent technical marvels in human history: snow and mammoth bone fortresses. Discovered through archaeological sites across Eastern Europe such as Mezhirich, Mezin, and Kostenki, these structures were neither makeshift huts erected randomly nor products of blind instinct. They were the culmination of a sophisticated architectural system, where raw materials harvested from massive hunted beasts were transformed into the ultimate survival shield. Today, let us peel back the frost of time to uncover the construction principles behind these fortresses, where physics, spatial geometry, and a profound understanding of fluid dynamics saved our species from the brink of extinction during the planet's darkest era. To understand why Ice Age hunters built structures with such unusual shapes, radically distinct from conventional vertical tent designs, we must first analyze their largest and most brutal enemy: aerodynamic wind pressure. When a blizzard howling at 100 miles per hour sweeps across the flat tundra, it carries massive kinetic energy, ready to level any obstacle in its path. If you erect a traditional square box structure, a visual and familiar design that modern humans naturally think of when starting to build shelter, you are effectively signing your own death warrant and that of your entire tribe. Why is that? Ask any modern aerodynamic engineer. Flat walls and 90-degree right angles are fatal weaknesses in high-wind environments. When wind strikes a flat wall perpendicularly, it cannot glide away smoothly. It is abruptly blocked at the point of impact, creating a massive positive pressure zone on the windward side, while on the sheltered leeward side behind, the airflow detaches and generates a violent negative pressure suction vortex. This pressure differential creates a force that tears the structure apart from the inside, causing square walls to rapidly break their joints, rip off roofs, and collapse entirely in the blink of an eye, much like a row of dominoes before a flick of the finger. Yet Paleolithic hunters, despite lacking differential calculus or modern wind simulation software, intuitively solved this problem through brilliant geometry: the parabolic dome and hemispherical structure. Looking at the framework of the fortress reconstructed from archaeological blueprints, we see a dense presence of naturally curved, massive mammoth tusks combined with large pelvises, shoulder blades, and thigh bones. These tusks were never planted vertically or stacked squarely like crude timber posts. They were counter-curved, interlocked, and tightly wedged together according to an extremely precise natural mathematical model that modern materials science calls optimal tension systems and multi-point load distribution. When the 100 miles per hour wind slammed into the Mammoth Bone Fortress, it encountered no flat obstructive surface to generate sudden pressure spikes. Thanks to the smooth, flawless curvature of the parabolic dome, the airflow was continuously bent, sliding smoothly along the rounded surface of the dwelling to form a seamless aerodynamic slipstream that enveloped the entire exterior structure. Drag forces were reduced to a minimum, completely preventing suction vortex formation on the backside. Furthermore, prehistoric builders appear to have chosen the inclination of the bone wall bases in ways that helped the structure remain stable under powerful winds. As the structure's own weight combined with compressed wind pressure, the force may have helped press the dwelling more firmly against the underlying permafrost rather than lifting it into the air. During severe storms, this interaction between weight, shape, and wind could have contributed to the structure's overall stability. It is a remarkable example of how ancient builders may have turned nature's destructive power into an important element of their survival strategy. Nevertheless, a bone framework boasting flawless aerodynamic design remains nothing more than a hollow wind cage unless it is tightly sealed and perfectly insulated. The second and most grueling battle on the Mammoth Steppe was the war for heat retention, with outdoor temperatures plummeting to -40 or -50 degrees Celsius, accompanied by severe wind chill effects. Lacking proper insulation meant blood in the body would rapidly thicken, leading to coma and fatal hypothermia after only a few hours of sleep in the bitter cold. Here, Paleolithic hunters successfully developed an advanced multi-layer composite material system tens of thousands of years before the modern concept of composite materials was ever coined. The first step in building the shell was draping thick animal hides, primarily reindeer, bear, and wolf pelts, over the mammoth bone framework, with long, dense undercoats facing inward toward the living room. These fur layers did not insulate directly through the hair fibers themselves. Instead, they trapped millions of tiny stagnant air pockets, blocking convective heat transfer from the inside out. Yet raw animal hides and fur alone remained insufficient to withstand relentless multi-day blizzards sweeping across the barren tundra. The truly decisive solution lay in the structure's outermost coating layer: high-density packed snow and surface sleek glazing techniques. Natural porous snow falling from the sky contains abundant air pockets and fails to retain heat well when pierced by strong winds. Recognizing this, the hunters mobilized collective strength to pile tons of snow over the hide-covered frame, then used their hands and primitive tools to continuously compact it to achieve optimal density. Next, they executed a brilliant engineering turning point. They splashed water or wet sleet across the entire exterior surface of the snow layer under the deep sub-zero ambient cold. The water instantly flash froze, combining with the compacted snow particles to form an ice armor shell as hard as cobblestone, completely sealing every microscopic gap and transforming the dwelling into a solid windproof block without a single heat leak. This unique composite outer shell created a critically important physical effect. It functioned as a heat consumer and storage unit, commonly known as a thermal battery. The massive mass of bones, hides, fur, and packed snow possessed a very high total specific heat capacity, allowing them to absorb, store, and slowly radiate steady heat generated by the central hearth throughout many hours, even long after the fire died down into midnight while everyone slept. The dwelling did not merely resist the cold passively. It turned the cold and surrounding materials into a core component of its robust protective shell. Inside the Mammoth Bone Fortress, once the insulation and wind-breaking shell successfully completed its warmth-retaining mission, a fresh mechanical challenge emerged demanding absolute precision: internal fluid dynamics and microclimate management. Picture an entirely enclosed living space housing a burning central hearth providing heat for a community of dozens living together. Without an extremely smart and precise ventilation system, toxic smoke, carbon monoxide, and soot from the fire would rapidly flood the confined space, suffocating and killing everyone in under 10 minutes. Conversely, if builders opened a ventilation hole too large or placed it in the wrong spot, all precious warmth would escape outward via convection in a flash, leaving the room as freezing as the outdoors. Ancient solutions relied on an exceptionally sophisticated stratified microclimate design. They positioned the central hearth in the middle of the house, but precisely positioned the smoke and exhaust gas vent at the absolute highest apex of the parabolic dome. Grounded in basic thermodynamics principles, that hot air and lighter smoke naturally tend to rise upward. All toxic exhaust gases were directed straight up and naturally expelled through this vent without lingering inside the room. Meanwhile, colder, heavier, yet oxygen-rich air sank and remained stable in the low stratum near the ground level, which served as the living, sitting, and sleeping area for humans. Furthermore, the fortress entranceway served as a miniature fluid dynamics masterpiece. Instead of opening a direct, straight doorway facing incoming external gale force winds, they designed an entrance passage shaped as a long, narrow, low and bent L-shaped or Z-shaped tunnel. When strong winds blew directly into the tunnel entrance, this distinct bent geometry created what is known as a suppressive vortex effect. The powerful wind lost momentum abruptly and swirled, neutralizing its energy within the narrow tunnel space and entirely stripping away its destructive force before ever reaching the main living space inside. Additionally, wind-driven snow blew inward, dropped and became trapped right at the tunnel's inner bend instead of flooding or chilling the living quarters. Inside the fortress at that moment lay a completely isolated world, an oasis of life amidst the Ice Age. While the outside remained a purgatory of deep sub-zero temperatures and howling gales tearing everything apart, the inner core maintained a stable, warm, safe atmosphere filled with breathable air. Looking back at these primitive architectural structures through the lens of 21st century engineering technology, we cannot help but feel astonished and humbled by human intellectual stature. The complex physical principles that Ice Age hunters independently deduced and applied tens of thousands of years ago, from aerodynamic load-bearing dome geometry and multi-layer composite insulation materials to natural convective ventilation systems and vortex suppression traps, closely resemble many of the same engineering principles that modern polar explorers, Arctic housing specialists, and even designers of extreme environment structures continue to apply today in storm-resistant geodesic shelters and scientific research stations across Antarctica and the Arctic. Snow and mammoth bone fortresses were never signs of primitiveness, barbarism, or backwardness as common stereotypes suggest. On the contrary, they stand as eloquent, sharp proof of superior spatial intelligence, long-term planning capabilities, top-tier social cooperation, and mathematical strategic thinking among our ancestors. They never lived by blind animal instinct alone. They knew how to observe, analyze, experiment, and master the harshest natural laws. In a wild world where nature constantly sought to wipe out vulnerable life, our ancestors chose neither escape nor desperate surrender. They chose confrontation, profound understanding of the universe's physical laws, shaping raw and rugged materials from game trophies and turning the coldest, most ruthless winter in planetary history into a sturdy, warm home filled with human warmth. That tenacity, extraordinary adaptability, and remarkable practical ingenuity not only helped them cross the threshold of life and death, but also paved the way for humankind to rise, master and dominate the entire blue planet in subsequent eras.